my dear VLSI aspirants, welcome to Deep Silicon VLSI YouTube channel. Let's have another design challenge, that is the output Y in the circuit below is always 1 when 2 or more inputs PQR are 0, 2 or more inputs PQR is 1, any odd number of inputs PQR is 0, any odd number of the inputs PQR is 1, for which combination the output will be 1 for this design. Okay, usually what we do is, for this we will calculate the actual Boolean function, Boolean expression. Accordingly we will choose the options, or we can see the design requirement for which condition output will be 1, like that. But however guys, with a simple shortcut you can finish this question in fraction of seconds. Yes, how it is possible? Guys, here if you observe this part of the design, you can understand this is a NAND implementation, isn't it? If it is a NAND implementation, it can be expressed in SOP form. Therefore, what is the output expression here? It is PQ plus QR. We know already, even we have given link in the description guys, how NAND implementation gives you the SOP expression. Okay, now here this is a NOT gate. Please don't think it is some other gate. It is a NAND gate only, acting like a NOT gate. Okay, therefore it is PQ plus QR whole bar. Now guys, what is this NAND gate output? It is Q and it is R, then it is PR. It's P, right? R. It's a PR whole bar. Now guys, what is the output expression Y? It is PQ plus QR whole bar into PR bar whole bar, because it is a NAND gate. By using De Morgan's theorem, if you simplify, you get PQ plus QR whole bar plus PR bar whole bar, and you know A bar whole bar is A only, hence it is PQ plus QR, again here plus PR. Finally guys, for this particular design we obtained the output expression PQ plus QR plus PR. Yes, for this given Boolean function, what might be the truth table? Because they are expecting the output to be 1. For which conditions? If you want to know the conditions, you need to draw the truth table. There is no any other way. Hence guys, here we can say PQ R and the output is Y. You know, for there are 3 variables, we will get 8 combinations: 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Now, if you take PQ plus QR plus PR, now this is 0 into 0, 0, 0 into 0, 0, 0. 0 into 0, 0, 0 into 1, 0, 0 into 1, 0, 0 into 0, 0, 0 into 1, 0, 1 into 1, 1, again 1 into 0, 0, therefore 0 plus 1 plus 0, it is 1. Again here, when you perform as per this Boolean expression, you will get the expression as this. Okay, now you see when output is becoming logic 1, for this case here. So output is 1 when 2 or more than 2 inputs are 1. In such combination only you will get output as 1. Hence guys, here you can say the right answer is 2 or more inputs PQ are 1. in this combination for this situation only, output will be 1. Right guys, this is what another design challenge. You need to know the logic optimization in VLSI. That is very, very important, and of course this itself you do when you enter into VLSI industry. Right guys, I hope you like the video, and please guys, if you are visiting the first time our YouTube channel Deep Silicon VLSI, please subscribe and extend your support, and please comment, we are listening. Right, see you in the next video. This is Shivaram signing off. Jai Hind.